this video, we are going to be looking at multiplying and dividing surds. Starting off with multiplication, there are a few rules that we need to learn, so let's go over them. The first one, root a multiplied by root b, just means that we multiply a and b together and add a square root sign. An example of this would be if we multiplied root 3 by root 2. Here we just multiply the two numbers, which gives us 6, and we add a square root sign. When we multiply surds, the number inside the root does not need to be the same, unlike when we add or subtract, where it does. The next rule is root a multiplied by root a just equals a. And the reason for this is if we rewrite this formula in terms of indices, we would have a to the power of a half multiplied by a to the power of a half. And if we have the same base number and we are multiplying, we add the indices together. So this would give us a to the power of a half plus a half, which equals a to the power of 1, which just equals a. The next multiplication rule, when there is a bracket with surds inside and we are multiplying the bracket to the power of a number, for example 2, this means we need to write this out as double brackets and then multiply across. We do not just square the numbers inside the brackets, which in this example would give us a squared plus b. So if you want to write these rules down and keep them as part of your revision notes. For this question, we need to multiply root 5 by root 10. So using our multiplication rule that we just went over, we need to multiply the two numbers together and add a root sign. So root 5 multiplied by root 10 equals the root of 5 multiplied by 10, which is root 50. Now, for all surds questions, before we give our final answer, we want to try and simplify if possible. To check if we are able to simplify, we can write out our list of square numbers. And from here, we can see that 25 is a factor of 50. So we can write this as root 25 multiplied by root 2, which gives us a final answer of 5 root 2. Next question, we have open bracket 2 minus root 2 close bracket to the power of 2. And to answer this, we'll refer back to our multiplication rule. So any surds inside a bracket to the power of 2 need to be rewritten as double brackets and multiplied across. So for this question, that will give us brackets 2 minus root 2 brackets 2 minus root 2. Multiply across. And that will give us 4 minus 2 root 2 minus 2 root 2 plus 2. Now we collect the like terms, which will give us 4 plus 2, which is 6, minus 2 minus 2 root 2, which is minus 4 root 2, and this can't be simplified down any further, so this is our final answer. For this question, we have 2 root 5 multiplied by 3 root 4. Now we need to answer this question in two parts. First, we multiply the two integers outside of the surd together. Then we multiply the two surds together. And then from there, we can collect the like terms as usual. So 2 times 3 is 6. And root 5 multiplied by root 4 is the same as root 5 multiplied by 2, which gives us 2 root 5. So, rewriting this question, 2 root 5 multiplied by 3 root 4 is the same as 6 multiplied by 2 root 5, which gives us a final answer of 12 root 5. I've got 3 questions here for you to have a go at to test your knowledge. Pause the video and attempt them, and I'll go over them once you're done. For the first one, we just need to multiply across. This will give us 4 root 5 plus 5, as multiplying the same surd together will cancel the root sign. This can't be simplified any further, so this is our final answer. Second question, we've got two brackets, so we need to multiply across. This gives us 24 plus 6 root 2 minus 4 root 2 minus 2. Now collecting the like terms, this leaves us with 22 plus 2 root 2 as our final answer. For the final question, we have a bracket to the power of 2, so we need to rewrite this as double brackets and then multiply across. This gives us 64 plus 16 root 2 plus 16 root 2, and 2 root 2 multiplied by 2 root 2 equals 4 times 2, which is 8, as we multiply the integers together and then the surds. Now collecting the like terms, this leaves us with a final answer of 72 plus 32 root 2. Now if you got all of those correct, well done, you are understanding the concepts of surds very well. There is another exam style question that we can work through before we take a look at Surds division. So again, pause the video here and have a go, and we'll go over it together once you're done. So for this question, we need to expand this bracket here and express our answer in the form of a plus b root c, where a, b, and c are integers. So let's write out the double brackets and multiply across as usual. This gives us 25 minus 5 root 5 minus 5 root 5 plus 5. Collecting the like terms, we are left with 30 minus 10 root 5. And as we can see, this is in the same format as requested in the question. So from here we can write down that A equals 30, B equals minus 10, and C equals 5. Now, looking at dividing surds, one rule we need to know is if we have the square root of A over B, this can be rewritten as root A over root B. An example of this would be if we had root 7 over 4, this can be rewritten as root 7 over root 4, and root 4 is equal to 2, so our final answer would be root 7 over 2. Now, if we needed to simplify root 12 over 49, first we will need to rewrite this as root 12 over root 49. And from here we would simplify both surds one by one. So root 12 can be rewritten as root 4 multiplied by root 3, which gives us 2 root 3. And root 49 can be rewritten as 7. So our final answer will now be 2 root 3 divided by 7. And we can't simplify any further, so this is our final answer. Looking at another example, we have root 18 over 25. Now to work this out, we would split it, and this will be rewritten as root 18 over root 25. Now we just need to simplify each surd. So root 18 can be rewritten as root 9 multiplied by root 2. Square root of 9 is 3, so 3 root 2 is our answer. And the square root of 25 is just 5. So going back to our question, this surd can now be rewritten as 3 root 2 over 5. This can't be simplified any further, and this is our final answer.